Need to test custom token validation logic in FastMCP, but don't want to rewrite the entire authentication stack? You'll see how to plug in your own validation function, whether it checks a Redis cache, queries a database, or implements custom business rules, while keeping the rest of FastMCP's Auth pipeline intact. This pattern gives you full control over token validation, without sacrificing the convenience of FastMCP's built-in authorization and client management.
From FastMCP server auth providers debug, import debug token verifier. Hash asynchronous validation, check against cache. Async def validate token, SDR, bool. Hash check if token exists in Redis, database, etc. Return await Redis, exists f valid tokens, token. Verifier equals debug token verifier. Validate equals validate token. Client ID equals API client. Scopes equals API access. MCP equals FastMCP. Name equals custom API. Auth equals verifier.
This demonstrates the custom token verification pattern, where authentication logic is decoupled from the core server through a pluggable verifier interface. The pattern treats token validation as a separate concern, allowing you to implement arbitrary validation rules while maintaining a consistent authorization interface. What makes this distinctive is its flexibility. You can validate against JWTs, opaque tokens, or even custom business logic without modifying the server's core behavior. The approach works by injecting a verification strategy into the server at initialization. The server delegates all token validation to this strategy, which can be as simple as checking a token prefix or as complex as querying a remote introspection endpoint. This separation of concerns means your server remains agnostic to token formats, while the verifier encapsulates all validation complexity. The pattern supports both synchronous and asynchronous validation, making it adaptable to different storage backends or network services. This pattern matters because it solves the problem of integrating with diverse authentication systems without coupling your server to specific token formats. It's ideal for microservices that need to validate tokens from existing identity providers, or for development environments where you want to bypass real authentication. The trade-off is that you're responsible for implementing correct validation logic. Use this for prototyping or custom scenarios, but prefer standardized verifiers like JWT or introspection for production systems. Let's break it down line by line.
From FastMCP server auth providers debug, import debug token verifier.
Imports debug token verifier, a mock authentication provider for development. It bypasses real auth checks while maintaining the same interface as production verifiers, enabling local testing without external dependencies.
Hash asynchronous validation, check against cache. Async def validate token, SDR, bool.
This defines an async token validator function required by FastMCP's Auth system. The async design prevents blocking during external cache checks, maintaining performance under load. It follows the standard FastMCP validation signature, takes a token string, returns a Boolean.
Hash check if token exists in Redis, database, etc. Return await Redis, exists f valid tokens, token.
This performs async token validation by checking Redis for a key prefixed with valid tokens. The pattern ensures stateless verification without database queries, optimizing performance for high-frequency auth checks.
Verifier equals debug token verifier.
Instantiates a debug token verifier for development environments. This bypasses production-grade authentication while maintaining the same interface, allowing you to test auth flows without implementing a full OAuth server. The debug token verifier is a test double that validates against your custom validate token function.
Validate equals validate token.
This injects the custom validate token function into the debug token verifier, overriding the default validation logic. The verifier will now use Redis-backed async token checks instead of the built-in debug behavior, enabling production-ready auth while maintaining the debug provider's convenience.
Client ID equals API client.
This sets the OAuth client identifier to API client, uniquely identifying this service when requesting tokens, required for proper token validation and scope enforcement in the debug auth provider.
Scopes equals API access.
This defines the OAuth2 scopes required for token validation, restricting access to only tokens with the API access permission. Scopes enforce granular authorization, preventing tokens with broader or unrelated permissions from accessing this endpoint. This is the standard OAuth2 pattern for permission control in API security. This closing parenthesis finalizes the debug token verifier instantiation, completing the auth provider configuration for FastMCP. It locks in the validation function, client credentials, and required scopes as a single immutable provider object. This pattern ensures all authentication parameters are set at creation time, preventing runtime configuration drift.
MCP equals FastMCP. Name equals custom API. Auth equals verifier.
This instantiates the FastMCP server with our custom authentication verifier. The name parameter identifies this API instance, while auth injects our token validation logic, enforcing security before any tool execution. This is the core server initialization pattern for all FastMCP applications. Debug token verification pattern. The debug token verifier provides ultimate flexibility by delegating token validation to custom logic, enabling everything from simple prefix checks to complex async database lookups. The default behavior accepts any non-empty token, which means forgetting to implement validation silently allows all requests through. This pattern bridges the gap between no security and full security, making it ideal for development and testing phases.
The verifier that trusts everything becomes the gatekeeper of nothing.